Hamburg's port is vital to the city's economy with 130 million tons handled in 2020, 92 million tons of which consisted of hinterland traffic. Even though transport by railway is growing steadily, cargo carried by trucks still accounts for slightly over 50% of the annual volume. Trucks drive more than 172,000 kilometers in the port on a typical workday. This means that up to 20,000 trucks enter the port's road network every day to take their routes through the port and into the hinterland of the region and Central Europe. To ensure the performance and accessibility of the heavily used infrastructure, it is absolutely essential to manage the traffic flow for trucks, especially at the busy traffic light intersections. A way needs to be found to reduce emissions from trucks which result from stop and go, to minimize delays in transporting goods and to use the existing infrastructure more efficiently. The Hamburg Port Authority looks for new technical ways to improve traffic control all over the port area by implementing a comprehensive and forward-looking traffic management system, incorporating new sensor technology. Responding to all detected traffic situations leads to a huge combination of measures over the whole network. With quantum-inspired optimization, the Hamburg Port Authority is taking a new approach to continuously finding optimal solutions to challenges with a large number of possible scenarios, all within seconds from sensor reading to initiating the signal sequence. This makes it the world's first real-time road network control using quantum-inspired technology. In 2019, the Hamburg Port Authority initiated this traffic innovation project to improve the traffic flow in the entire port region, which is currently in an advanced proof of concept phase. This initiative is the result of a partnership with the company Fujitsu Technology Solutions, which has provided the necessary technology to maximize the efficiency of traffic in the port of Hamburg. The port road network faces the challenges of a constantly increase in heavy traffic of goods that are transported on trucks at intervals of time that are difficult to predict, as well as commuter traffic with passenger cars. Thus we see a changing pattern of origin and destination traffic throughout the day. Due to cost reasons, limited space and environmental considerations, the road network cannot be expanded. Therefore, the existing network must be used more efficiently. The variety of different traffic sensors monitoring the traffic state and the need to optimize the traffic flow holistically by traffic signal control in real time requires a new approach of computing. The MOZART project is based on two essential components: the sensors and the processing unit. The independent sensors permanently send the measured traffic situation throughout the port from the induction loops and cameras to the processing unit. The processing unit, on the other hand, is responsible for calculating the traffic light phases in order to obtain the optimum total performance in real time. Essentially, the objective is to optimize green and red traffic light cycles so that the nodes coordinate with each other. This should result in shorter standstill time with the engine running, lower start and stop situations, reduced congestion, lower emission from unnecessary acceleration, and lower probability of collisions, and thus ensure a safer traffic flow. To achieve this, no more static signal programs are to be used. This means that signal controllers no longer execute fixed programs, but receive phase durations and sequences from a central command in a very short frequency. However, this also means that the optimal switching times, green and red time, must be found for each traffic light from a huge number of possible combinations. In addition, all existing sources must be taken into account and process them for real-time traffic light control. The unique advantage of overall network optimization is that not only the arriving vehicles per node are prioritized, but also the effects on the following nodes are considered. This allows emerging truck platoons to travel through the network without stopping. To achieve the challenging requirements, a new concept of traffic modeling and computational optimization was realized in the MOZART project by making use of classical high-performance computing and the new quantum-inspired digital annealing technology. A quantum computer, more precisely quantum annealer, can find the optimum combination within seconds. With a digital annealer, complex calculations are supported for a high number of possible scenarios in just a few seconds and enable operations in real time. This allows the optimization to be applied over the entire traffic system, resulting in a holistic solution that can map temporary fluctuation like planned events or local specialities in traffic flows such as construction sites. We can say that digital annealer already uses the benefits of great reduction in computing time in the case of this specific large-scale optimization task. For the first time, we can show that this new approach brings significant improvements of average speed in heavy load situations within existing infrastructure. The results also show that the requirements for operational real-time management are fulfilled by the very short calculation time. When we compare the status quo with the optimized signal control scenario by measuring the average speed of all vehicles in the road network, we see improvements of 10% and beyond this. The figure shows the speed of all vehicles in the road network. The model is now continuously filled by vehicles in a warm-up phase. Then the traffic light optimizer is activated. Already after a short time, we can see how the baseline degraded with increasing vehicle in the traffic model, while the optimized curve holds its level. When we only look at the percentage speed advantage, we can see that the optimizer holds a constant improvement in traffic control. A real network with more parallel and higher density intersections can make even more use of the global optimization. Now we embark on a new phase. Next year we will test the potential in the port with real data. The next steps will be to feed the model not only with real historic data, but also with real-time data, directly from the Hamburg Port Authority's Port Road Management Center, and to enable real-time calculation from traffic signal optimization. Additional features such as green time optimization for emergency vehicles or public transport are considered in the design as well. Finally, the prototype will stimulate the strategic real-time traffic management in the port. This technology will be a success factor not only for smart ports but also for smart cities. making both significantly sustainable.